going to try and catch up on time here. So Norwegian cyber range. We saw how basically today we cannot trust technology. One of the purposes of the cyber range is to provide an environment where the digital world and the real world can meet so we can start building trust. I work at the Department of Information Security and Telecommunications at the Norwegian University of Science and Technology. We're training around 600 students a year in cyber security. We have 300 students in the bachelor program, 200 students in the master's program, and quite a few. So we're one of the few universities that has both a bachelor program, a master's program, and a doctoral program. In the next 15 minutes, they want me to cut it down to 12, so I'm going to try, or even less, because we're supposed to. What are cyber ranges? What's special about the Norwegian cyber range? Some history, and a call for research partners and possibly beta customers. What are cyber ranges? This is a clip from Forbes magazine saying that you should have a cyber range in every enterprise. Cyber ranges are basically simulation. They like using the example of airline companies having flight simulators. So a cyber range is like a flight simulator that once a year you want your pilots to go in there and test what it's like to land when all of a sudden you do not have wheels on your plane, etc. Or, for example, police officers, where you go into schools, in the United States especially, and decide whether you're supposed to shoot or not shoot. And you actually have visual simulation here about that. So cyber ranges are simulation environments. This is, you have a cyber range in Sweden. We talk about it later at FOI. I took some of the slides from them. We're trying to cooperate with the Swedes, the Norwegians. And you see a cyber range, you have ranges for shooting, you have ranges for practicing exercises and breaching buildings, you have ranges where you practice blowing up things. You have driving ranges where you actually have fun, you play golf. You have ranges where you practice fire drills. And also you have ranges in a sense, one of the concept of ranges where you have crash testing. So you take a bunch of cars, right now the car we saw here, and you throw it against the wall and see what happens. These are what we're looking at the cyber range. There's quite a few cyber ranges in the United States. NIST has proposed a type of definition and standard. It's an interactive simulated representation of an organization's local network, etc. They're supposed to be safe, legal environments to gain hands-on cyber skills, both for product development and secure posture testing. We're using cyber ranges to assess and certify personnel. As I say, you don't want a pilot, you want to make sure a pilot on a plane has tested in his in a simulator 1,000 hours before he starts flying, etc., etc. We use it a lot for classroom education. So as I say, we have a huge volume of students that we're pushing through in terms of our ethical hacking courses, whatever. It's a lot of work to test this. I give some examples. We're also using it for competitions and exercises. I get into that later, what's going on with competitions. Hacking has become an e-sport. All right? Hacking has become an e-sport, and we want to profit on this. And of course, trend modeling. So what's so special about the Norwegian cyber range? To understand that is the Norwegian cyber range is taking a social-technical perspective. It's one of the things I tried to sell in Sweden for about 20 years, and it never worked. But the Norwegians seem to have a bit more money to spend. So basically, we have something called the CCAS. So we're centralizing, and we have a lot of public-private partnership. We have the triple helix, where we have government, academic, industry working together. And this is coming from the system group. It's a 7 million 3-year project that's funded by the Norwegian government and all these different types of agencies. So we're working both with the police, the military, the telecommunications company, etc. It's what we call a Kronsten project. keystone project, the capstone as some of you would call it. This is the official opening on the 4th of October with the Prime Minister. So the Prime Minister opened up the cyber range on the 4th of September. These are quotes that I translated from, actually I speak Swedish in Norway and they translate it into Norwegian, and now I'm going to translate it back to English, so it's quite funny in this regard. They quoted me as saying, it's an arena where you can exercise with complex social technical systems. And when I said that in Norway, they have quite a few climbing walls, which is great. If you're walking around, you see climbing walls all over in the universities and the hotels and the universities, etc. But they don't really have that great swimming holes. And the point is today is that you're training all these people to climb walls, but the problem is we are drowning in data. So everybody knows how to climb a wall, but no one knows how to swim. Now, as I say, we're stealing with pride in Norway. The cyber range in FUI started off in 2008 with a donation from the society, and they took about 10 years to get a position to about here. In Norway, we said we can do this in 3 years. If it takes 10 years for the Swedes, we can do it in 3 years. And we're using a social technical model, so we're using both a top-down and bottom-up approach to do our cyber range. So we're looking at models and scenarios, looking at tools and services, and we're looking at the infrastructure, all at the same time, having a bottom-up, top-down approach, using this so-called social technical modeling perspective. To understand this social technical modeling perspective, in 1989, I was tasked by the Swedish government to model United States, and I made a model of United States and modeled the entire United States. And I'm using this model now in Norway. Thank you, Sweden. What's interesting to understand the times in the 80s, this is what was going on in the 80s. This is from MITRE, it's an article from MITRE. I just want to set this one here now, is that explaining the history of security modeling. Computer security models are engineering models. How many people are civil engineers here? Or engineers? Yes. Good. Which has some freedom used in physical science. In physical science, reality comes first, and one uses a model to make predictions about the physical events and measurements. Now, I'm quoting this. This is not my quote. This is MITRE Corporation. This is what the basis of all our computer systems are designed on. If a prediction fails, the model is wrong. That's science. Now, engineers, the model comes first. The engineer decides what the system ought to do and then constructs a system that does it. If the system's output doesn't match the model, the system is wrong, not the model. This is the basis. We design these computer systems to say that we should work this way. No, that's the computer system. I don't work this way. And this is what we based basically the Orange Book and all these different criteria on. This is the model we're using. I came along and did something different. I proposed a different type of way of modeling and what is a secure system and not a secure system. 1994, I came out with this thesis, building all this. And we use these type of models to do things like model software supply chains, etc., to model reality and then go back and say, how can we engineer reality so that the system's secure? Here's some reports you can read later. Now, to understand what cyber ranges are, you have the different universities coming together in the United States, cooperating, etc. I don't have the time now. How many people are Trekkies and how many people are Star Wars? I don't know. Any Trekkies here? Do you know what the Kowalski Maru exercise is, right? Of course. Okay, they know, of course. So basically what you want to do, and you have this a lot in military and police training, is you want to put a manager and you want to make him fail so he understands what failing is all about. So he knows what it feels like to make a mistake. I don't want them to actually experience a cyber attack, but I want them to have the feeling of this. So you want people to actually know what it's like to make a mistake. And that's what the Kobayashi Maru exercise was about. And basically, Captain Kirk, he didn't like failing, so he went in and he hacked the system and won anyways, but that's not the other one. This is the opening again. It was the unit here. The cyber range is basically an arena where we start putting in technology and we experiment with technology. So we have all the different sites. This is, I'm going to go through this ethical hacking lab, and this is an adversary animation of an attack on the Norwegian net, and that's the Prime Minister running the software at the time. So we designed software. What we're doing is we're using our experience from large-scale student exercises to design this right now. So what we're doing is we've run these labs for about 6 years now anyway, so we might as well see if we can industrialize it. So what we have is we have our students taking these challenges at all level. This was at the 9/12 challenge in Geneva. Sorry. Well, actually, the Swedes came before us. We weren't happy about this, but in this challenge, we beat the Danish, so the Norwegians were happy at least that we beat the Danish when I went there. And then we have these things called Hackathons. So we're taking our experience with our students and putting it into the cyber range. So I say this was the challenge we had last, and say the things we're happy about. Notice that Sweden's not here. I don't know, you guys just want to accept the challenge, whatever, but you weren't in the challenge. But as long as we beat the beat the Danes, the Norwegians were happy. Next year we're going to do better. This year we came 10th. The year before we came 4th. So this is an example of the hacking lab where we set up red teams, green teams, blue teams, white teams, and the students participate in trying to hack and defend a network. So we have them putting our students through real-life situations. So when our students hit the market, they've worked with this. It's not that they read a paper written by somebody on a protocol and did something. Our students actually, when they hit the market, they actually seen what it's like to attack and defend their networks. Basically, the technical background is we're using an OpenStack model. We're using the different databases, etc. Using the right now we can manage 200 students participating at a time. I think we can scale up to 500 before we have to buy some new servers. But that's the situation. This was the adversary, sorry, it's spelled wrong, machine learning, where we took statistics about different types of hacking attacks, and we use, in terms of not so much artificial intelligence, you would call it, it's called agent-based simulation to attack the system. And here the Prime Minister had to decide how she would invest too. And this is an example where we won the competition in the Interpol Thinkathon. We designed a system to react and do forensic analysis of smart city attacks. So as I say, our students, we're educating them, we're putting them out in the real world, in the sense the real world that they have to compete with other students that are hacking and etc. So our students are battle ready, as you would say, instead of academic ready. This is an example too, is that we ran the NASA hackathon in Gjøvik, as you say, the only one in Scandinavia, and this is where we're actually taking people who are doing hackathons and teaching people that are writing code to write secure code. So we're going off and doing missionary work and selling it there, etc. So basically, again, the cyber range will be a national international environment to simulate and represent organizations. It can be used as a safe legal environment to test your personnel and organizations, to test your products and services, to test policy and regulations. Because basically, assurance comes down to this. Fundamentally, security assurance is about having capable, motivated people beating up digital systems in focus enough. So you're going to have to teach your students how to fight, how to penetrate, and then they're going to be strong. You can teach them how to do very good logical algorithms, etc. That's fine. And then you can buy Norwegian products. So a call for research partners and beta customers. As I say, we'll be offering in the future, in 3 years, we'll be offering cyber ranges as a service. The idea is that if you want to test, and say you want to sell a car in Norway, you should go off and have our students or whatever the personnel we have in our professional ethical hacking group attack it for 5 weeks before we allow you to drive a car in Norway. So basically setting up a driving range and shooting range for these type of products. That's the idea we're saying now. So we have security assurance as a service. And the cyber range, of course, we have an infrastructure. So if you're interested, become a partner. If you're interested in becoming a beta customer, you can contact me. These, unfortunately, which is interesting, is all the websites are written in Norwegian, but I'm sure the Swedes, if you try hard, you can understand Norwegian. All right, thank you.